So welcome everybody. My name is Scott, and today I'm going to be talking to you about how to get started with SQL Server DevOps. So when I made this talk, I had a very specific audience in mind, and that audience was anybody who wants to automate their database pipeline, but really doesn't know where to begin. Maybe today you've got a manual process and you want to automate it, but you don't really know how to get started. So what we're going to cover today is we're going to talk about what choices you need to make, what tools are out there, what challenges you're going to face, and I'll do an end-to-end demo of a pipeline using Redgate SQL Change Automation and Azure DevOps. And then I'll take questions at the end, so if you just want to start pumping them into chat, I'll address all of those at the end. So 30 minutes is not enough time to cover everything you need to know about creating a DevOps pipeline, but what I hope you get out of this is knowing your options and knowing how to get started. Because I find that a lot of companies just don't even know where to even begin. And so hopefully by the end of this, you will know how you can get on the path of automating your SQL Server development changes. So a little bit about me. I'm a software consultant based in Des Moines, Iowa. I am a developer, not a DBA, so that's the perspective that I have. So when I'm giving these tips and pointers, it's coming from a developer's perspective, not a DBA's perspective, but hopefully I can loop in the thoughts that DBAs have as well. I'm also a friend of Redgate, and I've automated quite a few SQL Server databases as well as Postgres databases too. And you can find me on Twitter. It's just my first and last name, Scott Sauber. So with that, let's get right into it. But let's first talk about what a manual workflow may look like today if you don't have any automation with your SQL Server. So Redgate put out this State of SQL DevOps survey for 2020, and in it, they asked who authors deployment scripts. And 55% of developers say that they are the ones who create the scripts, so that probably means they are also the ones who handle it end-to-end and probably review and deploy the scripts as well. And 25% of respondents said that the DBAs and developers work together to author the deployment scripts, and 20% of DBAs handle creating the deployment scripts, which means they likely also review and then also deploy those scripts as well. So those are the three kind of main workflows that I see, where a developer handles it from end to end. Maybe the team doesn't even have any database administrators in their organization. The other workflow would be some sort of hybrid where developers and DBAs get together and get those scripts out there. And then the other workflow that I see that's also pretty common is where a DBA just handles everything related to the database. So let's talk about why those manual processes are painful. I'm sure many of you have thoughts about why this is painful, and so this will come as no surprise to you. But first off, there's no source control for any of these manual processes, which is problematic because that means there's no traceability of who did what, when, and how they did it. And no, a comment at the top of a stored procedure or a view does not qualify as source control. The other aspect of a manual workflow that makes it painful is humans are involved, right? So humans make mistakes, and so a human may do something differently when they're deploying out to a lower environment than when they get to production, and that could cause issues downstream. The other problem I see with a lot of manual workflows with the companies that I work with is the development database and your prod database could be totally out of sync. So somebody may have made a change to a stored procedure or a view that is out in production, but it is not in one of your lower environments. So maybe your development database that you have locally. So then when you go to make that change, you don't know that their change is already out there, and you end up overriding the change that somebody else made because there's no forced continuous integration between your production database and your local dev database. So if we agree that this is a problem, let's talk about what is DevOps and how it can solve some of these issues. So I really like this definition of what DevOps is by Donovan Brown, who I believe is speaking later today. And he said that DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. So let's hit that first part real quick. People, process, and products. You need the people on board with your DevOps pipeline that you're about to set up, because the pipeline is honestly the easiest part of it most of the time. And in a lot of organizations, the problem comes down to people don't want to collaborate very well, or maybe not everybody's bought in and somebody still bypasses the pipeline that you have set up, and they'll go direct to production and not put their SQL changes into source control. So you need to get everybody on board and on the same page and in the same DevOps mindset. The next step is you need to identify what your process is. How do you go from your local machine all the way out to production? And what goes in between there? Depending on your organization, you may have some regulations or laws that you have to comply with. And so what steps do you need to put in place in your DevOps pipeline to satisfy those regulations that you need to comply with? And finally, this is usually the easy part, is you need the products and the robots to do the automation for you and deploy those scripts out into your various environments. And the last part is delivering value to our end users. Ultimately, everybody who's on this call right now, the only reason why any of us have a job is because we deliver value to our end users. Our end users don't care if we're using Kubernetes or whatever the latest hotness is. They just care that we're delivering value to them consistently, reliably, and as quickly as possible. And a DevOps pipeline will help you do that, do all three of those things. The other quote that I like is from Julie Gunderson from PagerDuty, and she said, "You can't change culture and process with a credit card. You can't go to Redgate.com and tell them that I'd like to buy one DevOps, please, and have suddenly your organization is doing DevOps. The tools are just one piece of that puzzle. You still have the process and the people, although Redgate documentation can also help you with the process as well. But ultimately, you need all three legs to stand on that chair in order to truly get the most benefit out of a DevOps pipeline." So if we agree that we should create a SQL Server DevOps pipeline, what does that look like? So you can get a lot more fancy than this and do things with Docker and SQL clone and all sorts of different products, but ultimately there's three basic necessities that I see. First step is just get your database into source control. Get all the scripts in there, any store procedures that you have, tables, views, functions, everything, just get it into source control. The next step is get your database deployments to be at most one click of one button. Don't have a process where multiple people need to be involved or have to do some coordination and make sure that there's some handoff there. Just get database deployments to be at most one click of one button in order to promote from each environment. And lastly, you want to have a build to verify each commit. So before you automatically deploy out to your lower environments, you'll want to have some sort of CI pipeline in place, continuous integration pipeline in place to verify each commit that you make and verify that that script that you made is actually valid. And we'll take a look at that here in a little bit. So again, back to that Redgate State of DevOps survey, we're talking about those three bottom things with the arrows next to them: version controlling your database, making automated builds for your database code, and automated database deployments. Now, I will say, I think this survey is probably a little biased because Redgate makes products that help with all three of these things. So the people who answer this survey are probably more likely to be doing those three things than the general population. So I would probably take all of these numbers and slice them in half of what's actually happening out in the industry, at least in my experience and the clients that I work with. So what you can do if you're trying to sell your organization on creating some sort of DevOps pipeline is you can show this to your manager and say, hey, more than likely our competition is not doing creating a automated SQL Server DevOps pipeline, so we can have a competitive advantage by implementing one of these so we can deliver to our customers more consistently, reliably, and more often. So you can use these numbers to your advantage in order to do your sales pitch throughout your organization. But why is this hard? Why on this last slide here are only half of people even doing version control? Because I don't know the exact numbers from an application perspective, but I'm guessing more than half of applications out there are doing some sort of source control. So why are these numbers so low? In my opinion, it comes down to a few different things. Number one, source control just has not typically been a first-class citizen by default in a lot of SQL tools. So things like SQL Management Studio does not come with source control out of the box. You have to buy a product from Redgate or another company to enhance SQL Management Studio to do those sorts of things. Whereas at an application perspective, from an application perspective, a lot of application IDs nowadays have source control built in from the get-go. So in my opinion, that's number one, is kind of the best practices haven't been baked in by default. Number two, some sins have been committed in your legacy databases. So things like linked servers, cross database hopping on the same server, not naming your column defaults, things like that. And we'll talk a little bit more about that later, about why those are problematic when you're setting up a pipeline. The other piece is it requires devs and DBAs to actually talk to each other. And I found going into a lot of different organizations that the devs and DBAs sometimes don't have the best relationship. Devs may think that DBAs are gatekeepers, and DBAs may think that devs don't know how to properly make a database, or their ORMs don't generate performance SQL, or things like that. So it requires these two groups of people to actually get together and talk it out and figure out what pipeline makes sense for both sides. The other concern that I've heard is DBAs think that they're getting cut out of the process, but they're actually not. If you're a DBA out there, I think if you think back to what your favorite part of your job is, I'm going to go ahead and guess that the favorite part of your job is not running scripts in Management Studio manually. I'm going to guess your favorite part of your job is designing databases, designing data warehouses, fixing performance problems, all of that kind of stuff. So DBAs actually aren't getting cut out of the process. They're actually getting freed up to spend more time to work on what they actually enjoy doing and not manually running scripts all over the place. The other piece that makes this hard is the database is stateful, whereas applications are not. So when you do a rollback with an application, usually you can just nuke all of the files you just deployed and redeploy all of your old files that you had previously. Whereas with a database, that's a lot harder to do because depending on what you're doing, you may not be able to roll back quite as easily. And we'll talk a little bit later about my opinion on what to do with rollbacks. So how do I do this exactly? We've kind of touched on why you should do it, but how do we go about doing this? So first step, again, put it into source control. This includes any schema structure that you have, so any DDL, any tables, views, functions, store procedures, whatever it is, get that into source control. The next step is to also source control your static data. So this is something that some people don't think about. So you should source control the data that is needed for your application to run. Things like lookup tables, roles, configuration data, that kind of thing. So get your schema structure and your static data into source control. The next step is you'll want to choose one of two approaches, either a model-based approach or a migration-based approach. And I prefer a migration-based approach. It gives you a little bit more control. And what a migration-based approach is every change that you make to your database is scripted, and then those scripts are committed to source control. And those scripts are then run in a very particular order. So those scripts may be named like V1, V2, V3. So V1 might create a table, V2 may alter that table in some way, like adding a column, and V3 may be dropping the table. You obviously can't run V3 before V1 in that case, or V2 in front of V1. So those scripts will run in a very particular order using a tool such as SQL Change Automation or Flyway. We'll talk about those tools here in a little bit. The other opinion that I have, and you don't have to do this, but this is just my preference, is I would like the database code and the application code to live in the same repository. And the reason for that is you will have one pull request for both the application code and the SQL code that you can code review side by side. And you don't have to do this dance where you have to get it merged. Like you might have a coordination problem where you have two pull requests in two different repos for the database code and the application code, and you need to get those merged in a very particular order. So if you put them all together in the same repository, you can have one pull request for both the application code and the SQL code. But again, that's just my preference. You don't necessarily have to do that. So a quick talk about Flyway. So Flyway is a product that was acquired by Redgate, I believe, about a year ago. And it's an open source tool. You can go check out the source code and submit pull requests if you want. It is a CLI tool. And again, it's a migration-based tool. So you just execute commands against the CLI, and it will perform the migrations for you. And it supports both version migrations and repeatable migrations. So a version migration would be something that you only want to run once, like adding a column or dropping a column, whereas a repeatable migration would be something you'd want to run over and over and over again, like a stored procedure. And the talk right after me goes deeper into Flyway, so I'm not going to go too deep into Flyway just yet. Then the other tool that I mentioned was Redgate SQL Change Automation. So it's very similar to Flyway in that it supports migrations, but it also supports showing the final state of your database. It's implemented as a Visual Studio and SQL Management Studio extension, and it integrates with MS Build, Azure DevOps, TeamCity, Octopus Deploy, and many other build products. So how do you do automated builds then? You can deploy your migrations to an independent database as a test run, either having a dedicated CI database or using something like Docker to spin up a database and tear it back down. And we'll take a look at that here in a little bit. You can also use a build tool. You would also use a build tool for this, such as Azure DevOps, GitHub Actions, TeamCity, Jenkins, Bamboo, Concourse, Drone, Travis CI. There's many different build tools out there that you could leverage. So how do you do automated deployments? You want to take those source control migrations and deploy those out to each environment. And as part of this, you'll want to swap out secrets, such as connection strings, because you likely have different databases you target for each environment. And you'll want to use some sort of deployment tool, such as Azure DevOps, Octopus Deploy, or some sort of build tool that I mentioned on the previous slide. So I'm going to propose a workflow as a starting point. You can tweak this workflow as you see fit, but I think this is a good starting point for any organization if you want to implement a pipeline. So step one is a developer adds their application code and SQL code, and that developer sends a pull request. You have one developer review the application code, while a DBA or maybe some senior person reviews the SQL code. And then once both of those are approved, the code is then merged into your main branch, and that code is built independently to verify the commit, and deployments at that point are a single click of a single button. So we are going to do a demo of doing this with Azure DevOps. And in the interest of time, I think I'm just going to voice over a recording because I'm running a bit short on time. So we're going to do an end-to-end, making the change locally, and then getting that pushed up to Azure DevOps, having it build, having it deploy, and all that kind of thing. So here's my recording. I'm going to go ahead. I'm in Visual Studio here, and I'm going to go ahead and create a brand new branch. And I'm going to make a change to this products table and add a new column. And after I do this, I'm going to go back to Visual Studio and leverage SQL Change Automation, which again is just extension for Visual Studio, but there's also an extension for SQL Management Studio if you'd prefer. And I'm going to hit refresh. And under the hood, it's using Redgate SQL Compare to check my database against what's the current state versus what's committed to source control. And I'm going to say import script, which it's identified that I need to do an alter table statement to add that column. I could also tweak the script if I see fit, but in my case, this script looks just fine. So I'm going to go ahead and commit this to source control. Again, you could tweak this table or this script if you so choose. You don't have to be beholden to the script it generates. I'm going to create a pull request to view my changes and get it merged in and get a code review out. So you can see it's saying here's my script I'm changing. But as part of this process, I've set it up so that a DBA has to be involved in this review. So I've got this other tab here where I've said that this is a required reviewer. So this tab right here is simulating the DBA. So then they can get involved and say whether they want to approve it or leave comments to make changes or whatever process that you want, whatever the comments that DBA has. So this is how a DBA can get involved in the SQL Server DevOps pipeline process. So this DBA is just going to go ahead and approve it, and I'm going to merge that in. And at this point, it's going to kick off a build, and it's going to verify that the change that I made has valid SQL and that I didn't break anything. And so you can see that the build was successful. And at this point, I'm ready to create a release. But just to prove that I didn't stack the deck or anything, I'm going to go to my production database. And you can see there, I do not have that description column there at all. And I'm actually deploying to my local host. So this is a common misconception with Azure DevOps is you don't have to be deploying to Azure. I just have a build agent running on my machine, and it's deploying it to my local machine. So in this pipeline, I did not set it up to automatically deploy, but I'm going to create a new release, and the only environment that I have is production. So I'm going to go ahead and say, yep, go ahead and deploy it to production. But normally I would do something like auto deploy to a development environment and then maybe manually promote it through QA, staging, and then all the way up to production, whatever environments that you have in your process. So you can see that deployment was successful. And if I check the logs here, it'll tell me that it ran my migration. So you'll see here in a second, I'll highlight it. And it tells me that I ran my migrations and it was successful. And so if we go back to the production database, you should now see that description column show up. So you can see right there, the description column has shown up. And so it took my change from source control and deployed it all the way out through my different environments. So how a lot of these tools work is there is a some sort of migration history table. In Redgate SQL Change Automation's case, they have this migration log table that keeps track of what migrations have been ran and what time they were run. And Flyway works very similarly. There's a Flyway schema history table that keeps track of what migrations have been run so that it knows the next time not to run those migrations. So let me switch back over here and turn off my screen share. So that was an example of using Redgate SQL Change Automation with Azure DevOps. Now, some common gotchas, depending on what your database is doing, you may hit issues if you're doing link servers or cross-database hops because you may have to set up those databases as well. So start not using link servers and hopping databases. I mentioned rollbacks. In my opinion, rollbacks are usually not worth the headache because how do you roll back a delete or a truncate? It's very contextual depending on what your script was doing because restoring from a backup may be okay for some tables that you deleted, but not other tables that may be a hot table where data is coming in constantly from different customers. So instead, you should try and fix the problem and roll forward. And with a pipeline in place, usually you can get your change out to production in usually under 10 minutes. So you will be subjected to some people challenges if you are implementing this for the first time in your organization, because as I mentioned earlier, DevOps is a mindset shift, just like Agile is a mindset shift. So the more you can force nobody has production write or alter schema, permissions, the better, because then everything has to go through the pipeline. And this requires devs and DBAs to come together and work together in order to have the pipeline in place that fits both parties. So some takeaways from this, hopefully I've brought some awareness to some tools available to you. And again, right after this, I believe, is a talk on Flyway, if you're interested in that. Hopefully you know to source control your database and auto build and deploy those source control migrations, as well as some gotchas that you'll hit along the way, both technology-wise and people-wise. You can absolutely do this. There's nothing technical that's preventing you from automating your SQL pipeline. I've done this for a multi-tenant database that got its start over 20 years ago, where we had to deploy a database to n number of customers, whereas most applications just have a single database that they need to deploy to. So there's nothing technical that's preventing you from doing this. The only question is, does your organization actually want to do this? I've also included some resources to some Redgate blogs and that State of DevOps survey that I mentioned earlier. So with that, I'll take any questions that you may have. And if you come up with questions later, you can feel free to reach out to me. Or if you're watching this stream later, my contact information, both for Twitter and my email, is right there. So with that, I'll take any questions. Looks like we've got one. We have a monolithic database, but multiple applications. Developers don't want us to start versioning database as it would be in one repo and other application would have the dependency. How would you approach this? Yep, so in that case, I probably would not put my SQL changes and my application changes in the same repository because you have multiple applications. You just have to be really careful when you're making those changes to make sure you're coordinating that deployment and making sure that you know, let's say like you're adding a required parameter to a store procedure, for instance, you'll have to make sure that your application can handle that scenario and get deployed, the database deployed at the same time the application is, but more than likely you're doing something like that today anyway. In general, I like to try and make sure my application and my database are in sync or can be rolled back easily. So my application can support the current database plus the current database -1. And so let's say I'm renaming a column. I might add a brand new column and start moving the data all over there, and then repoint the application to that column, and then keep the data in sync between those two, and then in a later migration, drop the old column once everything has been pointed over to it. So you can do certain tricks like that. It just kind of depends on your scenario.
That's a great answer. That was tough. The first time I automated deployments, hi, it's Grant, I'm back. Yep. The first time I had to automate deployments, it was the exact same scenario. So it was really, you gave a great answer. Yep.
Yeah, my current client right now is going through a similar thing where they have dozens of applications pointing to the same database. So I definitely am familiar with that challenge for sure.
Oh, God. Dozens.
Yep.
I had
yep.
5.
Probably
I
put
had
some
5, and it was a nightmare. So dozens. Ooh.
Yep. Ideally, you'd have some sort of API fronting that that everybody could point to that API rather than integrating at the database. But that's just my opinion.
Right. Oh, well, these things happen. Well, that was a great session. Thanks, Scott. I really appreciate it. That was I picked up a couple of tips and tricks, and I really, that was a good one. So thanks a lot.
All right. Thanks for having me.